So in this problem, we're looking at the inverse Laplace of e minus 2s over s squared plus s minus 2. And since we have the e minus 2s, this will involve the step functions uc's or hc's depending on the notations. So let's recall a little bit about that. So first of all, let us just set the notation so we know what we're talking about. So we're talking about this function here. So this function uc of t is equal to 0 for and 1 for t bigger than c. That's the function. So we know the general formula that says that for Laplace, uc of t f of t is equal to e minus sc, the Laplace, and you have to shift f, t plus c. So this formula is wonderful when one tries to compute the direct Laplace. But since we're dealing with inverse Laplace, we have to use another formula, which is just the shifted one, f of t minus c. Okay, this is e, it's the same formula, but one is adapted for the direct Laplace and the other one for the inverse Laplace. Okay, so here we go back. So we have e minus 2s over s squared plus s minus 2. We leave minus 2s separate, and we focus our attention on s squared plus s minus 2. And that is the Laplace of f of t. So I need to find the inverse Laplace of this. Okay? So for that, we need to do a partial decomposition technique. And we know that this is e minus 2s time 1 over, so I need to factor the bottom. And the bottom is s minus 1 times s plus 2, which gives me e minus 2s a over s minus 1 plus b over s plus 2. So partial decomposition techniques tells me that a, I'll leave it to the reader or the listener, that is going to be 1/3, and b is minus 1/3. So let us find now the inverse Laplace. So 1 over s minus 1 is et, so it's going to be Laplace of 1/3 et minus 1/3, and 1 over s plus 2 is e minus 2t. So I found f of t. So now I can use the formula. So this is Laplace of u2t, and we have to take this function and shift it. Okay? Whatever you see t, you put t minus 2. So it's going to be times 1/3 et minus 2 minus 1/3 e minus t times t minus 2. So the inverse Laplace of e minus 2s over s squared plus s minus 2 is equal to 1/3 e to the power t minus 2 minus 1/3 e to the minus 2 times t minus 2, which gives me 1/3 e t minus 2 minus 1/3 e minus 2t plus 4. So one way to see this function, and if somebody wants to graph it, this function here is a step function, and the answer is that for t between 0 and 2, we have 0. Okay, because we're multiplying. Oh, I'm sorry, I forgot the u2. Oh, there is no doubt about it. I forgot u2 of t. u2 of t. Otherwise, it's false. So u2 of 2 gives me 0 between t0 and 2, and 1/3 e t minus 2 minus 1/3 e minus 2t plus 4, and this is for t greater or equal than 2. So one can easily check that this function, you just use any utility to graph this function here, okay, and then remove the part between 0 and 2.